I am BJ at Seoul National University, working as a professor of neurology, and am one of those who love math as the science of reasoning and logic, and believe mathematics should be consistent without paradoxes. However, current number theory has many paradoxes and counterintuitive conclusions. For example, even though it is a common sense Cartesian geometry that we need a set of 1, 2, and 3 coordinates to locate a position in a line, plane, and space respectively, Cantor argued that it can be done by just one number. Cantor set is part of a number line that has a length of 0 but has infinitely many number points, which also leads to Devil's staircase. Cantor's diagonal argument with the result 2 powered by Aleph null is larger than Aleph null leads to there are infinitely many sizes of infinity and there is no largest infinity, and Vitalis set is part of a number line that does not have a length. It does not mean the length is 0, but simply cannot measure the length. They are weird, counterintuitive. And there are troubles in arithmetic of 0. All real numbers multiply by 0 equals 0, and we are told infinity multiplied by 0 equals 0, and 1 over infinity equals 0. However, if we multiply infinity on both sides, and then 1 equals 0 multiplied by infinity, which contradicts the line 2. And we are told we are not allowed to divide by 0, and wonder why. All these paradoxes, counterintuitive conclusions, and troubles in arithmetic of 0 are due to false beliefs in the concept of convergence and limit, Cauchy completeness, and Cantor's diagonal argument, which are the cornerstone of modern mathematics. Logical consistency is what matters in mathematics. After discussing flaws in these three concepts, I present a new number theory that is consistent, without paradoxes, counterintuitive conclusions, and troubles in arithmetic of 0. I'll begin with delusion in the concept of convergence and limit. Cauchy sequence is a sequence x of n of real numbers that satisfies the following. If for every epsilon larger than 0, there exists n in natural number n, such that absolute value of x sub m minus x sub n is smaller than epsilon for all m and n larger than n, then xn converges to a limit x in R, written as x sub n approaches x as n approaches infinity, and claims limit x sub n equals x. This proposition, if a sequence converges, then its limit is unique, will support limit x sub n equals x, and will lead to limit 1 over n equals 0. And I'm sure some of you are still wondering whether this is really true. The proof is like this. Suppose x sub n is a sequence such that x sub n approaches x and x prime, and you show x and x prime are the same. These are the proofs, and I'm not going to read each step, and let's look at the last step. Absolute value of x minus x prime is smaller than epsilon. Because this inequality holds true for all epsilon larger than 0, we must have absolute value of x minus x prime equals 0. Because this inequality would be false for epsilon equals absolute value of x minus x prime over 2 is larger than 0. Therefore, x equals x prime. This proof is supposed to be a proof by contradiction. Epsilon equals absolute value of x minus x prime over 2 is 0 is contradicted or false. Thus, absolute value of x minus x prime over 2 is larger than 0 is false, thus is 0, therefore x equals x prime. In order to make it simple to explain and understand, I will replace absolute value of x minus x prime as b and epsilon as a, and it will be like this. This proof by contradiction is flawed because the inequality that a is larger than b would be false for the assumption a equals b over 2 is larger than 0. What this proof shows is that the assumption a equals b over 2 is larger than 0 is contradicted or false, but does not show that b over 2 is larger than 0 is false as wrongly reasoned. A equals b over 2 is larger than 0 has two parts. A equals b over 2 and b over 2 is larger than 0. A is larger than b would be false for a equals b over 2 because b over 2 cannot be larger than b for any b. Thus, what it proves is that a is not equal to b over 2. b over 2 is larger than 0 alone cannot show the inequality that a is larger than b would be false, for b over 2 is larger than 0. Because a equals b over 2 is larger than 0 is true, is contradicted. A equals b over 2 is larger than 0 is false. A equals b over 2 is false because a is larger than b, thus allows to state a equals b over 2 is larger than 0 is false. However, a equals b over 2 is larger than 0 is false cannot be a reason that b over 2 is larger than 0 is false. Thus, we cannot reason that b over 2 is larger than 0 contradicts the inequality. Thus, it is flawed to conclude that b over 2 is larger than 0 contradicts the inequality, thus b equals 0 by contradiction. Let's consider a riddle. Suppose a is larger than 0 and a is larger than b. If a equals b over 2, then what is b? There is no answer for this riddle because there is no b that satisfies b smaller than b over 2. Thus, this is a nonsense riddle. Let's make it mathematical. Suppose a is larger than 0 and a larger than b. Assume a equals b over 2. Then what is b? We'll say that the assumption a equals b over 2 contradicts a is larger than b. Thus, we'll conclude a is not equal to b over 2 and will not say anything about b. What the proof claimed is like this. Suppose a is larger than 0 and a is larger than b. If we assume a equals b over 2 is larger than 0, this assumption of a equals b over 2 is larger than 0 leads to a contradiction. Thus, b over 2 is larger than 0 is contradicted. Thus, b equals 0. Thus, this reasoning is flawed. A flaw in the proof does not prove that the proposition itself is false. Thus, I show a counter example of the above proposition in order to show that the proposition itself is false. But before doing that, I show limit 1 over n is larger than 0 in the next video. Please make critical comments to this email. Thank you very much.